All right, so we are back at it again, and you can see that today what we're going to focus on is solving equations with multiplication and division. All right, so we're going to continue our conversation about solving equations, all right, and what that means. And it's really going to kind of go back to some of those same rules and properties that we've talked about at the very beginning with real numbers. Now, once again, we're going to start by connecting this to our system of equations work so we really understand what a solution is, right? What's happening when we solve an equation. Now, however, for today's opener, I only want you to do parts A, B, and C. All right, we really haven't talked about how to graph an exponential in this form. All right, so I'll go through this with you. But what I want you to do is go ahead and graph A, B, and C because you should know how to graph, all right, your linear function, your horizontal line, your absolute value function, and your quadratic function. And then I'll go through D with you. So pause the video, do those three graphs, flip it back on, and let's see how you did. All right, so here's my work for parts A and B. All right, so we know that this is a line. All right, it starts at 0, 0, and it has a slope of 2 over 1. And you can see that as I extend this, all right, I intersect the horizontal line y equals 8 at the point 4, 8. All right, so that would be my solution. Now, with my absolute value function, it starts at 0, 0. All right, that's our vertex. It has a rate of change of 2 over 1. And you can see this time as we extend, we get 2 points of intersection. So we have two solutions, -4 and +4. Now, here's my work for C. Once again, for our quadratic here, we start at 0, 0. All right, our A value is 2. All right, and then our 3A would be 6. And so you can see if I do that, I end up with two more solutions here, which is -2, 8 and 2, 8. All right, now, there's my work for D. But I'm going to go through that with you right now. So hopefully you did all right on parts A, B, and C. All right, now, when we look at part D here, all right, I'm going to start with y equals 8. That's our horizontal line. I'm just going to draw that in right here. All right, so you guys hopefully are feeling good about drawing your horizontal lines. Now, with this, our floor is still 0, so the k value doesn't change. So we have +0 out here, so my floor would be, all right, the x-axis. Now, what this 2 does is it's really going to just change our points by a multiple of 2 or a factor of 2. We talked about this making things narrower or wider, all right, in a previous unit. And so normally my y-intercept would be 1 above the floor, but now because I have this 2, it's going to be 2 above the floor. And then normally I would go up 2, but since I have the 2 out front, now I'm going to multiply that by 2, and I'm going to go up 4. And then normally I'd go up 4, but I'm going to multiply by 2, all right, and I get to that point. And really, if you wanted to know exactly without the kind of conceptual manner, you could just plug in your values, right? So 2 to the first power is 2, 2 times 2 is 4, right? If I plug in 2 for x here, 2 to the second power is 4, 4 times 2 is 8. So you could just create a t-chart, plug in those x values, and create that exponential, all right, graph, even though we didn't talk about this specific form. The important part here, though, is that we get a point of intersection here at 2, 8. So that's really what I wanted you to see, right? So we get one solution there. All right, so now how does that tie into our solving and the things that we've been talking about? So let's go back, all right? And once again, when we're solving an equation, we're really taking two functions and setting them equal and saying, okay, where do they intersect? What's the x value? All right, so once again, if I have my two functions, I'm going to set them equal to each other. 2x equals 8. Now, remember that this is 2 times x, so this is really a multiplication problem. So this is really saying, okay, 2 times what is 8? All right, so it's really going back to, all right, your multiplication tables. All right, so 2 times what is 8? 2 times 4 is 8. So whatever's behind my pen has to be 4, and in this case, that would be x. So x is equal to 4, and we're done. We've solved that equation. All right. Now, once again, we set these two things equal. So 2 times the absolute value of x equals 8. So notice this is still that same multiplication problem, right? 2 times what is 8? All right. And so 2 times 4 is still 8. Now, notice the only thing that's changed, all right, so whatever, all right, is there has to be 4. 2 times 4 is 8. But notice the difference now. All right, instead of being x, it's the absolute value of x. So now I have to do just one more additional step because we've talked about, okay, so absolute value is a distance from 0. So which numbers have a distance of 4 from 0? That would be -4 and +4. And once again, you can see that those are the x values. That's where those points of intersection occur, right? All right, so you can see that, okay, how does that tie in, right? Now, going down to our quadratic here, right? Once again, we set those two things equal. So 2x squared equals 8. So you can see that the problem doesn't change, right? It's still the same multiplication problem. 2 times what is 8? All right, so 2 times what is 8? 4. So that means x squared has to be 4. Now, once again, we're not finished, right? So now it's, okay, what number times itself gives me 4? And once again, there are two answers to that, right? So -2 times -2 is 4, and 2 times 2 is 4. And those are the two solutions we get, right? So you can see that that's where they intersect at -2 and +2. So when we're solving those equations, right, we're finding where do those two graphs intersect. Now, same thing here, right? 2 times 2 to the x is equal to 8. All right. 2 times what is 8? All right, same thing, 4, right? But this time it's 2 to the x is equal to 4. All right. And then once again, 2 to what power is 4, right? So we know 2 to the first power is 2. 2 squared is 2 times 2, which is 4. So that's what we would want. So x is equal to 2. And then once again, you can see that is where those two, all right, graphs intersect. Okay. Now, let's just look at the next set of problems here. Now, when we look at this, right, all right, we're going to do these without the graphs, but we're just going to try to translate, all right, what we have here. So this is 1/2 x, all right, and y equals 4. So once again, we're going to just set those equal to each other. 1/2 x equals 4. Now, so what this really is a division problem. We have a fraction, right? All right, this is half of something is 4. So what divided by 2 is 4, right? And that answer would be 8, okay? So x, all right, in this case would be 8, right? And if I think about plugging that back in, half of 8 is 4, all right? So if I did just a quick little check, right, 1/2 times x, right? I know x is 8 now, so 1/2 of 8 is 4. All right. So now, same thing here, right? We're going to set them equal to each other. 1/2 of absolute value of x is equal to 4. All right. So half of x, right? So half of something, I shouldn't say x, half of something is 4. And so notice it's the same problem, right? So whatever's behind my pen has to still be 8. In this case, though, it's the absolute value of x is 8. All right. And then we know that there are going to be two numbers that have an absolute value of 8, right? -8 and +8. All right, so let's just keep moving along, right? So set these equal to each other. All right, half of what is 4? So it's still 8. But notice the difference now is what is 8? X squared is 8. Now, here's the thing. 8 is not a perfect square, right? Because we know 1 squared would be 1. 2 squared is 4. And then 3 squared is 9. So here's what we know, right? 8 is between 4 and 9. That means x has to be somewhere between 2 and 3. It's going to be probably closer to 3, right? Because 8's closer to 9. And so what we want you to do on this is really just estimate, right? Okay, so, okay, x is going to be approximately -2.9, right? And x is going to be about 2.9. And that little wiggly equal sign means we're rounding, all right? So it means we're approximating. So if you get a number that's not a perfect square, just estimate that. Totally fine. All right, so let's go to this, right? 1/2 times 2 to the x is equal to 4. So once again, half of what is 4? Half of what is 4, right? 8. All right, so 2 to the x is 8. And once again, if we go through our powers of 2, right? 2 to the first power is 2. 2 squared is 2 times 2, which is 4. All right, 2 to the third power is 2 times 2 times 2, which is 8. So that means this would be x equals 3. All right, and notice I'm doing a little bit of side work, right? So this is totally fine, right? To help yourself, give yourself a visual to work through those particular problems. All right, so now here's the difference, right? Is that when we're graphing, right, we normally see, all right, the a value out in front like this. What happens though, a lot of times when you're solving, when you're an equation, is that they, instead of writing it like this, it's typically written like this, right? And this goes back to your properties of fractions. So I have my 1/2. Now, absolute value of x is really a fraction, but the denominator for absolute value of x is 1. All right, so 1 times absolute value of x. So remember, we multiply fraction, we do numerator times numerator. So 1 times absolute value of x is absolute value of x, and then 2 times 1 is 2. All right, so when we're solving, all right, most of the time, you're going to see things written in this form. All right, same thing here, right? Instead of seeing 2/3 x squared, you're going to see 2x squared divided by 3 a lot of times. All right, and so what we really want you to pick out of this and know is that this bar, this fraction bar, also means division, right? So this is what divided by 2, right? Something divisible by 2. And if I go back to what we just did and I write this, all right, like this, right? Okay, that's how I could have written the previous problem. And so notice this should just be what divided by 2 is 4. And notice it still gives us that same answer, right? Absolute value of x is equal to 8. All right. Okay, now, just a quick review, right? So when we look at linear equations right now we know linear equations can have one solution. All right? Okay, that's going to change a little when we get deeper into our unit, and we'll talk about why that is. Absolute value, right? We could have 0 solutions, right? We could have one solution, or we could have 2 solutions. All right, with quadratic equations, we could have 0 solutions. We could have one solution. We could have 2 solutions. And then we've seen with exponential, right, we might not have any solutions, or we could have one solution. All right, so understanding, like identifying the value, or excuse me, identifying the function first, right, helps you because then you know, okay, what kind of solution am I expecting, right? So if I know I'm working an exponential equation, all right, I know I'm never going to get 2 solutions with what we're doing right now. It either is going to be 0 or 1. All right, so understanding that will help you make sense of your solutions. All right, let's just look at a handful of problems here. All right, so let's just go through. All right, let's turn the page here and look at problem 1. And once again, what you're going to see, right, is that these are just really kind of simple problems, right? Now, sketch a quick graph, all right, before you solve. This is really just to help you understand, like, what kind of solutions or how many solutions should I expect? And all we really want you to do is do like a 15-second, all right, graph, right? Starting point, does it open up, does it open down? Graph your horizontal line for now. All right, so 4x, that starts at 0, 0. It's a linear function. It has a positive 4, so I know it opens up. 16 would be something up here, so it looks like I should get one solution. And so that's what we mean by just sketch a quick graph, right? Starting point, open up or down, draw your horizontal line, that's it. Now, once again, this is a multiplication problem. 4 times what is 16, right? So 4 times what is 16, if I can just cover that up a little bit, and the answer is 4. And notice I get x equals 4, and that's my solution. All right, now, looking at problem 2. This is an absolute value function. All right, it's an absolute value function. The starting point is 0, 0. It has a positive 4, so I know it opens up. So it looks something like that. And once again, 16 is up here. I should know now, I should get 2 solutions just from that quick graph. All right, so now, cover this up, right? 4 times what is 16? Notice that fact hasn't changed, right? It's still going to be 4. What has changed is what is equal to 4. So when I pull my pen away now, it's absolute value of x is equal to 4. And now I have to keep going because what numbers have a distance of 4 from 0, right? X equals -4, x equals +4. All right, okay, looking at problem 3. This is a quadratic, all right? It's a quadratic. The vertex would be at 0, 0. Just like that. It has an a value of +4, so we know it opens up. All right, okay, 16 is up here. And once again, I can see, oh, I should find 2 solutions here based on my quick graph. All right, so now once again, if I cover this up, it's a multiplication problem. 4 times what is 16? That multiplication fact hasn't changed. It's still going to be 4. What has changed is what is equal to 4, right? So x squared is equal to 4. And now my question is, okay, what number times itself gives me 4, right? 2 times 2 and -2 times -2. And those are my solutions. All right. Now, when we're looking with an exponential or working with an exponential like we are here, right? When we sketch this, you really just want to know if it's, all right, where the floor is, all right, and is it going to go up, an exponential growth or decay, all right? All right, and so when we look at this, right, the floor is going to be 0, and then this is 2 to the x. And so what we said is anytime our base is bigger than 1, we know it's going to go uphill. So we know it's going to be generally like this, and then 16 is up there. We should get 1 point of intersection. All right, so cover this up. Once again, the multiplication fact hasn't changed. 4 times what is 16? 4, all right? But what's changed is what is equal to 4. So 2 to what power is 4? And the answer is 2. All right, so that wraps up our video for this particular lesson. We'll continue this approach when we get to class. I will see you guys then.